So what current are we reading here? So you can see how we get the same thing, 0 point. The same, right? So let's check it out. So if I push it more to the middle, we get very close to what we got on this side. Okay. But when I push it to the end, it changes a little bit. And it reads for me. So on light 1, what are we getting?
There we go.
91. And now that we are using LED, let's check it out. We're still on amps. Look at how much this one is reading. Yes, but because we have one on there, so we check the voltage drop here. And what are we getting?
0.
Nothing.
We check across this one.
122.
This one will not come on.
Change.
Change the position. Possibly. But if we put another LED,
It won't
because
work.
it won't work because it's not what?
Not
It's not.
just the open.
Yeah.
Nah, push
It's
that one
not-
over.
Power. I want to test for continuity, right? We check between hot and neutral, hot and ground, right? So what do you think if I test between hot and neutral or hot and ground? What should I expect?
Beep or
no beep?
no beep.
No beep. So if I get a beep, what are you going to say?
We got a problem.
We'll
Okay.
fire Bruce.
So
You gotta say Zoof.
I have
Effed up.
one.
Bro.
So the switch is on, and I have one on the. I'm getting a beep. I'm getting a beep. Why am I getting a beep? Between hot and neutral, I'm getting a beep because the light closed the circuit, right? But so far as we have taken one light off, the circuit is open.
Yeah.
So now I can take it from the last one I check, and this one can be on, and that tells me that at least the wires are in good condition. No
They work
contact.
correctly?
They are wired correctly. Okay. So now every point there's no bridge. But if I put the light in, the light makes the circuit complete. So sometimes whenever we are checking for continuity, especially in motors is winding, right? So the current flows through, go to the lighting or the motor and returns. So if you check for continuity based on what the load is, it will give you what continuity, right?
So
But
the LEDs don't work?
the LED is electronics. Whenever you put in the power before it energizes and give power. So if you put in LED, it won't give you continuity. You get that? The same way if you pick a bulb, we can just check if the bulb is working well or not by just checking what continuity between the terminals. So if the light is good, then from the hot to neutral, I should get continuity. That means that the filament is in a good condition. But whenever
So what kind
If
of
I
reading
pick-
you get?
what
What
is
kind
it?
of reading you get on that bulb right there? On the
So
ohms,
here in
on
the
recipe?
ohms, we get about 20. One is 20 ohms and one is what?
What's the reason?
Based on the wattage.
wattage?
Yeah, based on the wattage. Okay. So with the LED, it doesn't give you continuity because there's an electronics system that will energize when the current flow. But this one continuous flow of current. And as the current is flowing based on the resistance, it causes that filament bulb to heat up. And when it heat up, it glows just like a stove. And with the gas in there, the heat causes the gas also to give light, making everything glow like a light to give you
On
light.
the LED?
Yes. No, I mean the filament.
On
the
the filament? On the
incandescent bulb, right? Incandescent bulb, right? So for light. Anyway, we are here to check our points, right? So we said the first point is in series circuit. What do? We have what?
Voltage.
We have the same current. Since we check it out, let me go ahead and turn the power hot. Do you remember the circuits?
Yeah.
They're only 15 and
So we go ahead and turn the main one on. We turn that 15 amps on as well. then we turn our circuit on. Now,
Wrong ball or what? Wrong circuit.
oh, this the breaker.
Did you switch the
It was
neutral to the
the
left side?
breaker. What do you say? Is it the breaker?
Yeah, that's what I.
Oh.
So we have one brighter than the other. But the basic fact that we establish is what? In a series circuit, what remains the same, Chris?
Current.
Current. Can you set the meter for us to measure current?
Correct.
Oh no, just less than what?
20.
Less than 20 amps. Actually, it's going to be less than
Oh,
1
the
amp.
meter's A.
So that's correct. Okay. And as I explained to you, here we are measuring alternating current. Some of the meters cannot measure DC current. So if your work involves you to measure DC current, then you have to buy a meter that can. So here you can see that on the current side, they just put what? Alternating. So if your work calls you to what? To check what current for UPSs and batteries and solar systems, then whenever you are buying your what? Your meter, make sure you can have a meter that can measure both the clamping for AC current or DC current, both of them. So this one I can measure the current by clamping on what? On just AC current. So if I clamp on this one here, whatever current I get, we'll take note of that. So what current are we reading here? 0.381 amps. 0.381 amps. If I measure the current on the other side, what should I get?
The
Same thing, because we are working on what? On series circuit. So you can see I will get the same thing, 0.385 amps. What about here?
The same.
The same, right? So let's check it out. 0.377 amps,
Got a drop.
right? And with that also, can I explain something a little bit? Whenever we are reading, falls between the line indication on the clamp meter. Can you see the line indication?
Okay, yeah.
So if we push it closer to the end or more closer to the meter,
Gotcha.
we get more accurate reading when the reading is what? Is
In the
between the
middle
two
there.
lines in the middle.
Okay.
Okay. So if I push it more to the middle, we get very close to the what we got on this side.
Okay.
Okay. But when I push it to the end, it changes a little bit. So if you let it fall between where the two lines are, that gives you more of accurate reading. So I put it on the other side, and we get what? The same thing, 3.88 something. So we have established the same. Current remains the same. What do you say about the second one? We said the sum of resistors. So here, these are what? These are electric loads. Okay, so these is consumed in terms of what? Wattages. Okay, so let's look at the third one. The third one, we said what? The voltage or whatever voltage we get from the source must be the voltage here plus what? The voltage there. Okay, so what voltage are we expecting from the source?
120.
Voltage.
120. We are going to measure voltage. Antonio, want to come and set a meter for me to measure voltage?
No.
By the sign, if you are measuring in terms of what? In terms of the millivolt or very small voltages, you set the range.
Range. Yeah.
So with that, we press on the range, and so now we have it as what? In what? In terms of a whole voltage, hundreds,
Hundreds. Yeah.
right? If it's you alone, you can put one lead into the what? The arm of the meter, and now be able to use the two hands to measure, and you'll be seeing the reading at the same time. Right. There are some of them that comes with what? A magnet attachment. So it's like a piece of what? Sling that's at the ears like that. So with that, you can just clamp in onto the what? Onto your any metal part. Then with your help of the lead, then you can measure your voltage. And this one too, if you don't have, you can buy it separately. You just attach it, and you be able to hold hang it up whilst you take your reading and you'll be able to say. Okay. We measure the current in the first the first reading. Sometimes the current you are reading is so hidden at a point that you can't measure and read the value at the same time. So then we use what? The hold button. So supposing I have it on the arms and I read the current, whatever current I'm reading, since sometimes the cable are so deep in the corner somewhere, whatever I read, I press on what? A hold. And what happens? It will keep the value. Now you bring it out there, you can read whatever value it has read. Because whilst it's hidden at the corner, you can't read at the same time.
Gotcha.
Right? So it is on hold. Whenever you take your readings and you're done, you press on the hold and that clears it out. It goes to what? The zero.
Okay. Cool.
Okay? The sine wave. So because I'm working alone, I just attach my lead to one of the meter, and I'm going to check between what? Between a hot and ground, or hot and what? And neutral. So if I have one on the ground, I put it on the hot leads and it reads for me. How much are we reading now?
122.
122 volts, 122.7 volts. Right. So that's the source, 122.7 volts. If we come here to light 1, let's see what we are going to read here. It's okay. So on light 1, what are we getting? 31.4 volts. Right? 130 what? 122, 31.4. So what should we expect here? Very close to what?
90.
Yeah.
Okay. We deduct this from that. So let's check what we are expecting here now.
There we go.
91 what? 91 volts. Okay. So here, depending on what the wattage of the bulb will determine what the voltage drop is. Just like what the resistance value there will determine what which one will have more voltage drop and which one will have less voltage drop. Right. So with regards to the brightness, also it depends on what? It depends on the wattage. Right. So whatever we have here is going to be what? This plus that. This voltage drop plus this voltage drop must add up to the supply voltage drop. So let me put it on voltage and check it out.
Now you just touch it.
And we bring it closer and it read the voltage. Okay, but here just telling you that there's a voltage present. There are some of them also that beeps. And sometimes even it lights on this side. Let me see.
I'll bring the bag in tomorrow.
What that mean?
That means that the cable has power.
Oh, has power.
Like
Just
this
has
is
new
on
power.
contact
Okay.
Line tester.
Oh.
You use this one, so not contact voltage tester. Okay. Any other questions? We put these on that, so that now that whatever voltage now will come here will be the what? The total 120. We have put the circuit off, right? And guys, anytime you are working on anything, please treat it as if what? It's energized, even though it's what? It's off. Okay? Because what can happen is...
So that way we're gonna give the whole voltage to that?
Yes.
What are you doing there?
What do you say? Yes, thank you. What do you say, Chris?
No, I didn't say anything.
Connect this because now the power is just going to.
Oh, it's closing you.
Yes.
Right there. Okay.
Right. So it's like I've breached what the two wires.
So now that
whatever
won't
power
turn on?
flows now, just flow that and get back to the source. Right. So what? The amount. Any other questions?
I just don't understand the purpose of a series if it's not going to be bright.
Okay. Yes, that's right. So most for residential, we hardly do series circuit. Right? But we want you to understand the principle when it comes to what series and parallel. Right? So for almost all our circuits in the homes are all what parallel.
Yeah, or
So
we're
if you know
pushing
what
120.
voltage it needs, then 120 throughout for everything.
What it's sending back.
Because the plastic is
I don't know.
It's true.
The magnetic field.
Is what?
Magnetic field?
The magnetic field, yes. So why is a meter reading? Tell us a little about the magnetic field.
The line had an energy, but the magnetic field is to go out, but the neutral the wire, the charging and go back, so then it's zero.
Do you understand what he's trying to explain to you?
no, they cancel.
So
itself
here,
out.
what happens? Yes, cancel out itself. So the current is flowing through the hot in one direction, and the current is returning by the other direction. And we say that whenever you use your left hand to hold the conductor, if your left hand is in the direction of the current, your fingers will be the direction of the what of the field. And because one is going and one is coming, equal magnitude. So the flux generated by one is cancelled by what? The other in the opposite direction. Whenever you clamp your clamp meter on a cable, what happens is it's picking the magnetic flux generated or created by the current flowing through the what? The cable. The stronger the cable, the stronger the field. So when I clamp this one on it, based on the strength of the magnetic field, is calibrated to give me what? The corresponding current that has created the flux. So this one is picking what? The flux around what? The cable. And with the calibration, it will tell me that, okay, this is what? This amount of current, 0.78 amps of current. Because of what? The flux, the strength of the flux created by the running current. Right? So now if I should clamp on what? Both conductors at the same time, what do you think it will read? Zero. Because now the current flows and flows through the light and return. So because equal but opposite direction and the same magnitude, one flux cancel the other. And this read what? Very close to what? 0 volts. 0 volts. Because the magnetic flux has what? Has cancelled each other. Do we get a LED? We're now going to go and check the current. And you must understand why we must all what? Replace our incandescent lamps with the LED. So he said whenever this one was on, it was what? 0.7 what?
786.
786. And now that we are using LED, let's check it out. We're still on amps. Look at how much this one is reading. This one is what? 0.07 something.
Yeah.
But the other one was what? 0.7. So more or less this one is using what?
Less in.
10% of what this one is using.
I'm switching the LEDs all over the house.
Yeah.
So if your house you have all everything in incandescent bulbs or filament bulbs, your light bill is what? Is 10 times what you could have used if you use what? Your LEDs.
Use LED bulb.
So how many of you have all your light LEDs?
I try.
Hopefully.
Anytime I lose,
Can you even tell the difference? Squilly ones is what? Is compact fluorescent. Relatively they consume relatively less to what? To that.
But these are
But still LEDs consume much lesser to those compact fluorescent.
Yeah.
What do you say?
This is the banner.
Yes, this is better to the compact fluorescent lamps. Right? So if we can replace what? All your what? And some people what they think is the LED just can what? Daylight.
What about those?
Yes, those are compact
The tubes?
fluorescent. Yes.
So
They consume relatively
low.
is high compared to LEDs.
It's the bad one.
What do you say? Okay. Where is the other bulb? Let me use
LED?
this one to see. No, the same filament bulb.
I thought it wasn't supposed to come on.
Which one?
I thought LED lights didn't work with the series.
Yes, but because we have one on the.
Fluorescent.
Okay, let's. Go ahead and check. Can you hold this one, please? It's not even on at all. Okay, let's measure the voltage drop across this one.
Oh, voltage, range.
Yeah, okay.
Okay.
That's good. So we check the voltage drop here. And what are we getting?
0.
Nothing.
They always say it's better.
I hope you haven't pressed the hold. So this one gives us
122.
122.
You were talking?
We check
They all say
across this one.
Yeah, they all say
0.
Volts. We check across this one.
122.
What's the explanation? What explanation can we give?
Because you're measuring the same line.
No.
Explanation for that because it's weird.
Yeah, because
Yeah, it's very weird.
your home run power is coming from here and hitting here. You would think it's going to give this power first
Yes,
before
just
that.
using this as a jumper.
Even they should have at least 2 volts.
It should have
Yes,
like a
right.
little bit of something.
Yes.
Yeah.
Okay.
If the voltage is 0, that means no current.
The same potential,
Yep.
right?
Mhm.
Because of the what? The filament,
Filament is
whatever voltage is here, it flows through the back, right? So now the same
It's only
potential.
feeding this.
Well, it's weird. It's weird that you don't read voltage on that one.
How will I explain that to you guys?
Yeah. Magic.
No, it's not magic. The principle.
So,
What do you say?
so you check the 2 hot ones on the. It gives you only
It will be
difference.
zero at the same
Zero.
thing, right?
Be
Zero
zero.
because there's no difference in potential,
Same thing with this.
right? So if you check here, as we said, if you check the what, the voltage on the same line is going to be what?
missing because it's missing the neutral.
Zero.
Yep.
Oh, no.
Yes, but if
That's just
with
a
the
wire. It's
So
acting
that's
as
the
a wire
jumper.
only.
That's one of the jumper.
so here it's just using this as a load, right?
It's a load.
And this now is just a jumper.
jumper.
Current just flow through.
Okay, but how this converting in the jumper? No.
Because remember that is continuity. So the current just flow through
Going to the
and
filament.
gets to this point. Unless we give it a neutral connection here, then this will come on.
Yeah, because it's gonna be parallel.
And vice versa. Let's just change the position.
Yeah. Can we change?
Then this one will not come on.
Oh yeah.
Let's
Change.
change the position.
This will not turn on.
No, possibly it should be the same thing. Vice versa.
Yeah.
You think so?
It-
Oh.
Yeah, this is the back one.
This is the same thing. So you're just using this as a jumper.
Oh yeah.
Check the voltage.
And now we put it on voltage and check this one here.
But how that working? We have no neutral in it.
What do you say?
No
No,
neutral.
the neutral flows through the bulb because
Okay.
this gives you when we check from one
Oh,
to the
okay.
so the neutral flows through the bulb and gives this one. Right?
0.
So zero because you have the
Zero.
same
The
potential.
same potential.
Okay.
Oh.
So I have to be able to explain why this is using that as what as a jumper and now this becomes what the load in the circuit,
Oh okay.
right?
Is it because of that diode that's in there you were talking about?
Yeah, but I'm not able to convince to explain
So
that
this
principle.
It's acting as a neutral right here.
Yes,
right?
because the neutral flows through
Yeah.
this and come back here. Yes.
It's like this.
don't do this.
Right. Okay. Any questions?
Yeah.
Yes.
Any explanation? Any explanation? How this converting jumps in the jumper?
Yeah. In the theory.
Because
Not even line.
But if we put another LED,
It won't
because
work.
it won't work because it's not what
not only
It's not-
the
it's a
open
Single pole. What is
because the different mode.
And
Yeah.
put that one over there.
Continue. What is it?
What
that
voltage
one over
we
there.
have? Nada?
If you put
No continuity.
No, not continuity. No
so it
complete.
can flow through that and get there. The power just stops on this side,
Okay.
right?
So-
what's the time now? 9
So
yes.
LED and incandescent does not work together in a series circuit.
But if it's parallel, it will work.
It will work.
Right? Yes.
That's it. That's what we come up with.
Unfortunately, I couldn't help you enough with this explanation.
No, that's all right.
Right. Any other question related
wait.
to that? Yeah.
Did you turn it on?
Yeah, I just turned it off.
Oh,
when you
okay.
were taking
Oh,
the
let's
light
say, hey,
off.
don't.
That's why I told you always treat what any electrical system as what as hot or energized.
Thanks for watching, and if you haven't subscribed, please do. See you next time.